Good morning. Welcome to A for A levels. This is my tutor. Today we're going to go through A level mechanics, paper 42, winter 2020. Let's go. Two particles P and Q of masses 0.2 and 0.5 kilogram respectively are at rest on a smooth horizontal plane. P is projected towards Q with speed of 2 meters per second. Write down the momentum of P. The momentum is 0.2 times 2 is 0.4 kilogram meters per second. Okay. After the collision, P continues to move in the same direction with speed 0.3 meters per second. Find the speed of Q after the collision. So the momentum before the collision is 0.4 equals the momentum after the collision 0.2 times 0.3 plus the momentum of Q is 0.5 V. So 0.5 V. 0.4 minus 0.06 is 0.34. So V equals 0.68 meters per second. Next question. A car of mass 1,800 kilograms is traveling along a straight horizontal road. The power of the car's engine is constant. There is a constant resistance to motion of 650 newtons. Find the power of the car's engine, given that the car's acceleration is 0.5 meters per second square when speed is 20 meters per second. So this is the car. This is the driving force, which is equals to power over velocity, or E over 20. This is the resistance, which is 650. Okay, so resultant force equals to mass times acceleration. Resultant force is P over 20 minus 650 equals to 1800 0.5. P over 20 550 P equals to 310 watts. Okay. Find the steady speed which the car can maintain with the engine working at this power. So again, power is FV. V is power over force or driving force. If it's a steady speed, the driving force will be equal to the resistance. So the power is 31,000 over 650 equals 1,000 divided by 650. So in three significant figures, it is 47.7. Okay. A block of mass m kilogram is held in equilibrium below a horizontal ceiling by two springs as shown in the diagram. One of the string is inclined at 45 degrees to the horizontal and the tension in the string is T Newton. The other string is inclined at 60 degrees to the horizontal and the tension in the string is 20 Newton. Find T and M. Okay, this question you can use triangular of force, which will not be a right angle triangle. So I'm going to use resolution of force. Going by horizontal, resolve horizontally. T cos 45 equals to 20 cos 60. T equals to cos 45. So in decimal place is 14.1 Newton. Okay. So what we have here is the weight is 10 m. So resolving vertically, t sine 45 is 20 sine 60 equals to 10 m. M equal 20 sine 60 divide 10. So the answer is 2.73 kilogram. Okay, next question. Question 4. The diagram shows a velocity time graph which models the motion of a car. The graph consists of 4 straight line segments. Car accelerates at a constant rate of 2 meters per second square from rest to a speed of 20 meters per second over a period of t seconds. It then decelerates at a constant rate for 5 seconds before traveling at a constant speed of v meters per second for 27.5 seconds. The car then decelerates to rest at a constant rate over a period of 5 seconds. So here is 5. Here's 27.5. Here's another 5. Okay, t. So the first part, the gradient is 2. 2 equals to 20 over t. T equals to 10. Okay. Given that the distance traveled up to the point in which the car begins to move with constant speed is 1/3 of the total distance traveled, find v. So this here is 10, here 15, here is 42.5, here is 47.5. Let's see. So I divided into 2 parts, 2 triangles. First, total I can divide it into 2 triangles. Total into 2 triangles. Cannot. The 3 parts now. 3 parts. Okay. So first part, half times 10 times 20. Plus second part. This part A. This part B. The second part is V plus 20. Height is 5. 5 over 2V plus 20. So this part is 1/3 of the total distance. So the remaining will be 2 times what the first part. So it'll be half. This is a trapezium. 32.5. 27.5. 2.5 plus 27.5. The height is V. Correct. Okay, that's correct. That's correct. So this can cancel off. Okay. So half times 10 times 20 is 100 plus 5 over 2V plus 50 equals to this one add together is 40, 60 is 60, 30, 15. So 15 minus 5 over 2 is 25 over 2V equals to 150. V equals to 6 times 2, 12. That's it. A particle is projected vertically upwards at speed 40 alongside a building of height h. Given that the particle is above the level of the top building for 4 seconds, find H. So this is a building. H. Particle moves up and come back down. H. So the displacement is H. The initial velocity is 40. The acceleration is minus 10. So you're finding T. So using the formula S equals to UT plus half H equals to 40T minus 5T squared. Minus 40T plus H equals 0. So assuming both the roots are alpha and beta, so you're giving alpha minus beta is equals to 4. So quadratic equation alpha plus beta is equals to minus b over a. So it's 40 over 5 equals to 8. Alpha beta equals to h over 5. Alpha minus beta square equals to alpha square minus 2 alpha beta plus beta square. Alpha, this is 4 square plus 2 alpha beta plus beta square minus 4 alpha beta. So 16 equal alpha plus beta square minus 4 alpha beta. 16 equals to 8 square minus 4h over 4h over 5 equals to 48. H equals to 60 meters. Okay, there we have it. I'm using pure maths way of finding, so it's a bit easier. 1 second after the first particle is projected, the second particle is projected vertically upwards from the top of the building with speed 20. Denoting the time after projection of the first particle is t, find the value of t for which the two particles are at the same height above the ground. Okay, so here on the top, this is 60 already. Huh? 20. Yeah. U equals to 40. Huh? Same height, same height. So S A equals to minus 10. Same height. U is given. So the question should be at the same time. So they missed out this. Huh? So using the same formula, first particle, S equal S equals UT 40T plus half minus 10 T square. So this is 5T square minus 40T plus S equals 0. Second particle, S plus 60. Because it's 60 above the ground. Equals to 20. 1 second later, so T minus 1. Or T plus 1. Plus half minus 10 T plus 1 square. So you need to just substitute the T lah. So this is S 40T minus 5T square plus 60 equals to 20T plus 20 minus 5T square plus 2T plus 1. Always this is the problem. You're supposed to T minus 1. 1 second later, not plus 1. Minus. Minus. So you have 40T minus 5T squared plus 60 equals to 20T minus 20 minus 5T squared plus 10T minus 5. You can cancel the 5T squared. So you have 20T empty. Empty. Okay, something is wrong. This should be S minus 60. Because it's 60 meters above the ground. So you have 35 T 0.5 seconds. Okay. Block of mass 5 kilograms is placed on a plane inclined at 30 degrees to the horizontal. The coefficient of friction between the block and the plane is mu. The force of magnitude 40 Newton is applied to the block acting up the plane parallel to a line of grid. So the block begins to slide up the plane. So it's position of limiting friction. Oh no. So friction R. R is here. This is your weight, which is 50 Newton. Then friction is downwards because we're sliding up the plane. So this is F. This is mu R. So it's limiting friction really. R equal, this is 30. 50 cos 30. 25 root 3. So if we slice up the plane, then 40 upwards must be greater than 50 sine 30 plus mu R. So 40 larger than 50. This is 50. 50 sine 30 is 25 plus 25 root 3 mu. So 25 root 3 mu is smaller than 15. Mu smaller than 15 over 25 root 3. 3 over root 3. This is 3, this is 5. So cancel, you have mu 5 root 3. Okay, sure. And the force of 40 Newton is applied horizontal in the vertical plane containing a line of greater slope. The block does not move. Show the criteria the least possible value of mu is 0.152. So this one F, limiting friction is smaller than mu R friction. F is the same. This is 50. R. So now R equals to 40 cos 60 plus 50 cos 30. Yeah. 20 plus 25. Okay. So F mu R plus 50 sine 30 equal to, this is in equilibrium, it doesn't move, 40 sine 60. Okay. So mu 20 plus 25 root 3. F, sorry. This is F. I need to put that first. F equals to 20 root 3 minus 25. So 20 root 3 minus 25 smaller than mu r. 20 plus 25 root. Mu is larger than 20 root 3 minus 25 over 20 plus 25 root 3. Okay, 152 equal. Or least value is 0.152. This question is a bit difficult. Particle P moves in a straight line starting from a point O with velocity 1.72 meters per second. The acceleration A on the particle t seconds after leaving O is A equals to 0.1 t to the power 3 over 2. Find the value of t when the velocity of P is 3 meters per second. So when t equals to 0, s equals 0, v equals 1.72. V is integrate a dt. V equals to t power 3 over 2. V equals to, at 1 is 5 over 2 over 5 over 2 plus c. 1 over 10 times 2 over 5. 1 over 25. 5 t to the power 5 over 2 plus c. So c is 1.72. E equals to 1 over 25 t to the power 5 over 2 plus 1.7. So when v is 3. V equals to 3. 3 equals to 1 over 25. E to the power 5 over 2 plus 1.72. E to the power 5 over 2 equals to 3 minus 1.72 times 25. Get an exact value here. T equals to 4. Okay, when you get exact value, definitely is right. Answer. Find the displacement of P when from O when T equals to 2, giving answer correct to 2 decimal place. Displacement is integrate B dt. S equals to T 25. D 5 over 2. It's 1.72 equal 1 over 25 t to the power 7 over 2 over 7 over 2 0.72T C. S0 T 0. So C 0. S equals 175. So T equals to 2. Two 175 to the power of 7.2 plus 1.72 times 2. Oh, I can have all this funny thing. It's 3.57. 3.57 meters. Okay, good. Is there any more question? Yes, one final question. Oh, you got 8 questions. Two particles A and B of masses 0.3 and 0.5 kilogram respectively are attached to ends of light inextensible string. The string passes over a fixed smooth pulley which is attached to a horizontal plane and to the top of an inclined plane, which makes an angle of 30 degrees with the horizontal. String is taut and B can move on the line of greater slope of the inclined plane. The force of 3.5 Newton is applied to B acting down the plane. Given that both planes are smooth, find the tension in the string. So let's put tension as T. This will be 5. A. So at B, 3.5 plus 5 sine 30 minus D equals to MA, 0.5 A. So 2.5 plus 3.56 minus D equals 0.5 A. This is equation 1. At A, D equals to 0.3 A. So 1 plus 2, 6 equals 0.8 A. A equals 65.8, 7.5. 5 meters per second square. Therefore, D equals 0.3 times 7.5. D equals to 2.25. Okay. It is given said that the two planes are rough when each particle has moved a distance of 0.6 meters from rest. The total amount of work done against friction is 1.1 joules. Use energy method to find the speed of B when it has moved this distance down the plane. Down the plane. So gain and loss of so it's move 0.6 meters. So this is 0.6 meters. So the height 0.6 times sine 30, 3 meters. Okay. The speed of B when it's moved this distance down the plane. Okay. So the 3.5 Newton force is pulling B only. Total amount that against friction. Total. So we must take total kinetic energy. So again in kinetic energy, half times the total mass is 0.8. Times V square. Work done against friction is again in energy. So it's 1.1 joules equals to work done against in the direction of friction force is 3.5 times 0.6. 3.5 times 0.6. This is the work done by the force on B. Plus the loss of potential energy times 10. 0.3. So V 2.5 meters per second only. So that's it. I'll check the solution again. So all seems to be in order. So the answer is 2.5. Okay, 2.5. Looking seems to be very short, but it's what you should know. Now, that's it. If you need this paper, put down your email in the comment section. Subscribe to this channel. You have more. You'll be notified when there are more videos coming on stream. That's it. Bye for now.